Okay, so for today we're doing parametrics, and what is the difference between parametrics and what you did before? Well, this is an example of how we have a new system. You have a thing with x in it, and y in it, and t in it. Those are the three things, x, y, and t. And so, look, they're not functions, because doesn't pass a vertical line test, doesn't pass a vertical line test, doesn't pass a vertical line test, but they can make kind of cool drawings. All right, so I want to go off to the side and just show you. This is your classic parabola. It's an upside down parabola. And a lot of kids understood if time was down here and the height was here, that if a ball was right there, we knew two things, the height and the time. Do you get that? Could we have also known, but not graphed, a third thing, which would be like, for example, not only how high the ball is, but how far away from you it is. Like lateral distance. Okay, so like if I had a ball and I threw it out your way, it would have a height at any time. And it could also have the how far away it is from me. Okay, so what you can do with parametrics is you can graph three things at once. So instead of having time down there, let's say this is lateral distance from the thrower. As in not the distance up and down, but the distance like, horizontally. Okay? So then this might be representing 8 feet off the ground and 2 feet laterally from the thrower. The ball has gotten 8 and 2. And then how do you get the time in there? T equals 1 is right there at time 1. And I know it seems kind of cheating. You're just throwing in a third thing. But that's what parametrics can do because they have 3 variables. Do you get in the real world? Things don't have to follow the vertical line test. You got a bird. He flies straight up to a branch up here. And then he flies over here. And then a second later, he flies back across where he was. And now he flies back down to the ground. Do you get what I'm saying? Birds' paths don't just follow a normal path, right? So you have to have multiple variables to be able to handle that. Okay, so if I said this was at time 0, he was here at time 0.1 seconds, 0.2 seconds, 0.3 seconds, 0.4 seconds. He was at all of these places. And this wouldn't be time down here. This might be your lateral distance. And this might be your height off the ground. You got 3 things going on. All right, so I'm just trying to give you a perspective of what this is. It's a new system. It's got 3 variables instead of 2. Can you still graph it? Yes, we can still graph it on a normal graph. But instead of just x and y, we have to have a third thing, and that's time. And so we just graph x and y spots, but then we label them with time. So if you're graphing these, you need an x and a y and a t. So we call these TXY charts, and they're really critical. They'll tell you at time 0, this is where we are at this point, XY. So at time 0, let's say we are at 1, 2. That might be like right here. At time 0, when we start this thing, the bird is already off the ground. It's right there. At time 1, let's say that the bird is like right there. And that's at, let's say, 5 feet away from us and probably 3 times as tall as it was. So let's say this is 5, 6. So you've got 3 things in all of your graphs, t and x and y. All right, go to this page, please. So on parametric equations, and this is like, I don't know what color this is. This is a fade between pink and tan or whatever. I want you to process this. I think that this is written in an overly complicated way, but they've got x, they've got y, and then at each dot you'd have to label a t equals. So let's say he starts there at t equals 0. Do you see the directional arrows along the way? They're showing what direction this thing went, and that's also important on parametrics. Is they start at a certain place, they go a certain direction, and they end at a certain place. You know, on a normal graph, if I just had a straight line that was like, we never even said where you started, where you ended, or which direction you were going on that line. Okay, but these parametrics do that. They tell you where you started, which direction you went, and where you ended. Okay, so they got lots more info than regular graphing does. But one of the things that we do is we help you to learn how to get in a parametric equation and change it into a plain old-fashioned rectangular graph. But the problem with that is that you can't, it'll only work for straight lines. No, actually it'll make curved lines, but you can't do ones that won't pass the vertical line test. But we can change parametrics to rectangular. All right, so let me just ask you, is this parametric or rectangular? Got to be able to look at these and go, oh, that's parametric because it's got t. Not just t, but it's got three variables. It's got x, it's got y, and it's got t. And this f, that's just labeling a function. That's not a new variable. That's like f of x, you know, or g of x. That is, these don't count as variables. They're just f of x or g of x. All right, please go to this page. This is a typical problem. A typical problem says we've got this x equals thing, y equals thing, and for t is greater than or equal to -2. All right. Well, thankfully, they already put these in. They knew that t would slowly increase because it's got to be bigger than -2 or equal to -2. So they already filled that in. Let's just find a few spots. Would everybody please figure out what x and y are? Right here and right here. So what are you talking about, Mr. Server? We'll stick -2 in here, where the t is. And then figure out what you get. Graham, what'd you get for the first one? When you stuck -2 in for x, you got? Excellent. Have you done y yet?
Yeah.
What'd you get?
Also -5.
All right, cool. Then at time -2, and I know that's annoying. We often have told you you can't have time be negative, but if you think about going back in time, you know, like I can say t minus 5 minutes could have been like 5 minutes ago. So it's not an impossible thing. All right, so at time -2, this thing was at -5, -5. So that's way down here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right there is where it started. And what do? I label t equals -2 right by that. t equals -2 by that dot. All right, let's make another point. Cooper, what'd you get when you stuck in -1?
-4 for x and -3 for y.
-4, -3. Everybody graph that point. Unlabel it with t equals -1. All right, do the next one, everybody, and we'll see who I call upon for the t equals 0 spot. Vivian, what did you get when you stuck in 0?
For x, I got -3.
Yep.
And then for y, I got -1.
Perfect. I think you guys are getting the idea, right? You just have to keep graphing spots. The biggest difference is that in this case, it looks like it's just staying on a straight line. And it's just that you have to label a t equals on each spot. All right, now, could this thing be different than a regular rectangular? Oh, yes, it is, for sure. Even though it's a straight line, it's got a start. It'll have an end. So I won't put an arrow on the end, and I'll have a direction. We did start down there at the bottom, and we put the direction arrows in the middle. Okay, now how could we have gotten a curve? Do you get, I could have made this a squared, and you guys have known this long time, haven't you, that when you got a squared, you get like a curve in the line? Same thing happens here. If you get one of the variables a squared, you can get a curved line. All right, move on. Everybody get to this page. Now, it says convert to function form. I would prefer to say convert it to rectangular. Because you got used to converting things to rectangular on our last test. Now, on that note, some of you came in this morning and took it fantastic. Some of you haven't yet. I understand you were busy and maybe you were taking an English test instead. But how many of you have not taken the test that we all took on Friday? Raise your hand if you're still waiting to do that. 1, 2, 3, 4, 5, 6 people. Okay, 7 people. All right. So your two choices are, you could take it on Wednesday during Mass, but I understand some of you already have another test scheduled for that. But on Wednesday during this class, we are opening up another opportunity. Okay, so during this class hour, other kids are going to be taking a quiz on parametrics. We're going to allow you to take that home and take it instead. Well, other kids will take it here. But if you need to take the test that you missed on Friday, so many kids have that scenario that we're opening up an extra time you can do it during class Wednesday. Okay, so if you want to study for that, you can count on. My ideal world is you take it during Mass, but I do understand multiple kids have a conflict there. Then try to get it done Wednesday during class. That would mean Thursday morning you wouldn't have to get up early and drive in early to come in Thursday. But if Wednesday during class doesn't work, then your last chance is Thursday morning before school. Okay? So those are your chances. You had this morning. Some kids already came and did it then. You'll have Wednesday before school, Wednesday during my class, and then Thursday before school. After that, your test is significantly late and we need to talk. All right, so if I wanted to convert this over from polar, well, wait a minute, there's no polar here. There's no r's and thetas, right? But there's x's and y's and there's t's. And that's a sign that this is in parametric. Can I get it so there's no t? Yes, I can. And that's my next job, is to teach you how to do that. All right, in my opinion, the first thing you always do is you make a TXY chart, whether you're graphing it or whether you're converting it. So everybody make a TXY chart. Now, you just saw this one 2 seconds ago. If you have a short-term memory, you can go, okay, it was -2, -1, etc. But let's just do the first couple points, just those two. Do you guys remember that it was -5, -5, and -4, was it -3, I think? Okay, good. Now, why do we need that? Because we're going to get the t out of there. We're going to replace the t limit right here. Remember the whole t was time thing? It was the extra variable that was in there? We're going to get t out of there, and that won't be that hard. But this part, we're going to need this to replace the t with an x limit. All right, so before we get too far into this, I want to just have everybody take this equation, and then this is really easy. At first you're going to be confused, but it's really easy. Solve for t. Just take that top one, solve it for t. What's t equal? You might be like, well, I don't know what, it's got an x in it. Yeah, it's x plus 3. Raise your hand if you had x plus 3. Cool. Then do the same thing for this one. What's t equal to down there? Well, I'm going to add 1 to both sides. Now I got y plus 1. Oh, and then you divide by 2. There we go. T equals y plus 1 divided by 2. Does that make sense? Okay. Now, somebody's going to figure out what we should do.
X plus 3 is equal to y plus 1.
Because this and this are equal, this must equal this. Yeah, they're both t. So, x plus 3 equals y plus 1 over 2. Now you might be like, okay, so what do I have to solve for? Nothing. Just like before, when we converted, as long as you got it over to just x's and y's, did I? Did I get it over to just x's and y's? Yeah, then I'm done. Unless it tells you have to solve, and if it told you to solve for x, it wouldn't be that hard. You just subtract 3 from both sides. If they told you to solve for y, you just multiply, clear the fraction, multiply by 2 everywhere, and then subtract 1, and you'd be solved for y. It wouldn't be that hard to solve it for x or y, but there's no point. But, what's the big but? It's not done. Do you remember this part? He's saying we had to have that. Somehow we have to have this limit, because otherwise this is a regular equation. It doesn't have a start, it doesn't have an end. It goes on forever in both directions, and we don't know which direction it's going. This one, we saw it. It started at -5, and then it kept going up and to the right forever. So how do we get this to have the same kind of limit? We say x has to be between two things. But what does x have to be between? Well, x has to start at -5, because look, see, at the first time that this is allowed, it was -5. And then is it going up or down? Yeah, -5 went to -4, which will go to -3, -2, -1, 0, 1, 2, 3. It's going up. So from -5 to, does it have an ending point? Nope. Goes to infinity. X could, there's no, like, we could just keep on putting in more and more, like, let's make this 0, let's make this 1. Let's make this 2, let's make this 3, and x would eventually just keep getting bigger and bigger and bigger and bigger. So x goes to infinity. The way to think of it is, this one only had a limit on one end. So this one will only have a limit on one end. There is the final answer. What do? You solve for t, set them equal. But don't forget this limit part. Yes, question?
Isn't it or equal to -5?
Ooh, I think you got me. Hold on just a second here. Thinking. Got some weird thing in my... I gotta put a box over it somehow. I didn't mean to. So -5 was less than x was less than infinity, and you're saying this should be or equal to, and I think you're right. I'm double checking this. It was equal to -5 when we put in -2, so I agree. It's or equal to. Thank you for catching that. Okay. Is that rectangular? Yeah. Why?
Because it has X in there.
Only has x and y's. What if I had r equals sine theta? Is that polar? Yep. Do you remember converting polar over to x's and y's? Do you remember this deal where you could times both sides by r, and then you got r squared, and that was x squared plus y squared? And r sine theta was really y. Does that ring a bell? If you don't recognize that, you better study for that test. 7 of you haven't taken it yet. But okay, so that was converting from polar to rectangular. Now we're doing, what's this new kind called again? Parametric. We're converting from parametric to rectangular, and don't forget the limit, the limiter. Yes?
Why do we just do an x limit?
Good question. You only have to have one limit. Either you could limit x or you could limit y. You could do either one, but you don't have to set a limit on the other because it'll automatically follow. I could try to explain that further, but for right now, if we were to look at the graph of this thing, started here and it goes up that way, as long as you stop the x from going any further, it'll automatically stop the y from going any further in that direction.
Okay, so we could have done the y.
You could have, but my advice to you is going to be always do the x, and there's reasons, but
Okay.
yes.
So would an answer on the test have like 2 spots where you put answers, one for the equation and one for the limit?
A lot of times we will try to remind you that there's a limit, but if you forget it, it's on you. You've got to have that. So, no, I'm not going to promise that there's always a spot for it. But we do tell you over and over again, don't forget the limit. But people forget it all the time. All right, go to this one, and we actually have a few problems to do, and then I can hand back your tests from yesterday. All right, so this first problem, convert to non-parametric form. I would just call it, there's a reason they don't just call it rectangular, but I'm just going to call it rectangular. You're just converting it to rectangular. All right, do you remember me saying always start with a TXY? Now you do. John, what's the first T I should try?
0.
Good. Everybody put in T equals 0, see what you get. Ariana, what did you get when you suck in T equals 0? X is,
-3.
Y is
Y is -2.
-2. Okay. And this one's kind of weird because it starts at 0 and it ends at 1. So all you have to do is those two, and then you graph the whole thing. Jack, if I stick in 1 for T, what do I get?
-4.
Nope, the first one is not -1.
Oh, wait.
Put a 1 right there.
1,
1, and then,
4.
yes. Now graph those 2 points. Remember, you just graph it normal X and normal Y, but then you label the T on there. So John Rafferty, how do I graph the first point?
It's -3, -2. Then you add T equals 0 next to it.
T equals 0 right next to it. Very good. All right. Leah, what's the other point and what do I put by it?
1, 4, and T equals 1.
There it is. And T equals 1. Do these things have a direction? Yes. At time 0, you start. Time 1, you end. And you put an arrow in the middle. Why don't you think I put it on the end?
Because it's not continuing on.
It's not going forever. It stops right there. Otherwise, it would assume it's a normal line that goes forever. Okay. Is this done? No, I've graphed it. But I haven't converted it into a rectangular yet. So, do you remember that deal where we solved for something? Cooper, lead us through this. How are we going to change this over?
You're gonna solve for T on both of them.
Okay. What do you get for this one? T equals
T equals X plus 3 over 4.
X plus 3 over 4. Nice. That's just taking this and adding 3 to both sides. And then, okay. And then solve the other one.
You get Y plus 2 over 6.
T equals Y plus 2 over 6 is correct. And then we still have T's. So?
Set them equal to each other.
Exactly. So then Y plus 2 over 6 must equal X plus 3 over 4. Mission accomplished, kind of. So, Leah G, can you tell me what's missing? The limiter. Yep. And I'm not calling it a limit just because that normally means lim of the function as x approaches. So a limiter, a way to limit the function. And in this case, we can't use t because otherwise we're putting a third variable back in it. So you can't just grab the t equals thing. So instead, you make an x equals thing. And use the same signs they did. If they said or equal to, you can say or equal to. Can I just call it 0 and 1? No. Look at your chart. What was your x's? It went from -3 to 1. So -3 to 1. Raise your hand if you feel like you got that. Cool. There's only one more twist that we have to put into this whole thing. We just did that homework problem together. You should definitely do this one on your own. These are basically the same exact thing, except, ooh, look, Mom, it's got a curve in it. Okay, it's just the same exact thing. It's gonna get, your graph's just gonna curve a little bit when you actually make those points. You always start with an XY chart, TXY, sorry. And you graph enough points, you want more points when you're making a curve. 2 dots will give you a straight line, but if you have like 3 or 4 dots, you can see where a curve goes way easier once you got 3, 4 dots. If I only had 2 of those, you'd be like, where the heck's the curve? Okay, so, then on this page, we have cosine and sine. And don't think that it instantly makes it freaking impossible. It does not. You still have a TXY chart. Let's everybody go to this one and let's make a TXY chart. Okay. What's my first T? Alex K. What's the first t? Negative pi over 2. And when I use that negative pi over 2, I need to go back and put it in here. And you have to be able to just go do cosine of negative pi over 2. And if you can't, then you didn't ever learn circle trig. I'm going to go make a picture because I always do. And I go, where the heck is negative pi over 2? Oh, yeah, that's down here. That's this thing. That's where negative pi over 2 is. And then I got to know those numbers. This is 0 comma negative 1. And then if I was going to do cosine of that, it's the x. And so what's the answer? 0. Because that is really 0. Because it's the x value at that spot. All right, so x is 0. So I have now got a 0 there. And then I want to do sine of that same thing. Well, that's kind of handy that I've already put in my little drawing because it's the same exact drawing. Sine is the y, so that must be 1. See how those points are not impossible to make? Oh, I just read my point and I have written my point wrong. You are very accurate today. Very nice. Only person to catch both mistakes. Maybe somebody else did, just didn't say it. Yup, there was a negative 1 right there. Okay. I just made the mistake when I drew it, and then it was the y, so I was doing that right. All right, so it should be negative 1. So now if I was going to graph this thing, how do you graph that? You don't graph the t's, remember? You graph the x's and the y's. So 0, negative 1's right there. We just say, oh yeah, that was at t equals, and notice t doesn't always have to be time. T can be an angle, like in this case. Math rewards careful people, so I got to be more careful. Zoom in on this thing. There. Negative pi over 2. How many do we have to do? Do you remember that cosine and sine sometimes lend themselves to curves too? I mean, think about it. Cosine is a wave. Sine's a wave, right? So I need multiple points. If I just do the endpoints, you won't see the curve. So what's between negative pi over 2 and that's on the way to pi over 2? What's in between those two? 0 is another point you should test. So 0 and then pi over 2. And if you get these 3 points on your chart, you'll have enough of a curve that you'll be able to know, oh, it starts here. And then you get your 2 more points and you know that it's going in that direction, but it stops. It stops wherever this is. So again, let's just do one more point. Let's say we're trying to do 0. So that means we're really trying to do cosine of 0. Remember, that's 0 degrees. So hopefully you know where that is. 0 degrees is this guy, this one. It's putting a dot there. That's at 1 comma 0. Cosine's the x of it, so it's 1. Sine's the y of it, so it's 0. So if I want to make this next point, I'm going to put it at 1 comma 0 and put it at t equals 0. Then the last one, you put in pi over 2 in these 2 spots, which is up here. Now, is it possible it could still be a straight line? Yeah, it's possible. But a lot of times with cosine and sine, you're going to get curves. Okay, so got to admit, I did 2/3 of that problem for you. So finish that one and then try that one. And then you will understand parametric at least well enough. This one's going above and beyond what I would need for you to know how to do. So we're going to stop there. Scribble those out. Now, this time of year, I get it. The weather has gotten nice. You've got 8 million things to do. Some of you have sports and APs and IBs, and you have lots of time pressures. This test is coming on Friday. I'm starting today, and there's a test on Friday of this stuff. Okay, you cannot afford to get behind. So do some homework tonight. Check it with the answer key. And I am going to find a way to assess whether you are doing homework this week. That could mean that tomorrow I'll say, okay, take out last night's homework and take a screenshot of these 3 pages and send it to me. Okay, I need you to do your homework, and I gotta find ways to make you want to do math when you have other things you have to do. I get it, but you need to spend 10, 15 minutes on math each night. If you do, you'll be fine on Friday. If you get behind and lost, you'll be toast on Friday. And then if you're like, oh, I just missed Friday then and I make it up, well, then you're getting way, way behind, because then you'll have to learn the new unit. Because, of course, on Monday, there'll be a new unit starting, and now you're behind a unit. That's not a good place to be. Some of you are there right now because you haven't taken the test for the last test. So get that done on Wednesday, that if you missed Friday's test. All right, and that's all I got for you for today.